Now we will learn about the symmetry in polar graphs. Symmetry means being the same in both the sides, identical, like butterfly, half of the, not all butterflies, but many butterflies, left side and right side are symmetrical. If I have a line and I have a shape like this, then even the right side must be just like that, symmetrical. Okay, it should be exactly the same. Now this is a line of symmetry. Now, the speciality in polar graph is if the polar graph, the equation, the function is cos theta, then the symmetry is in polar axis. If any question is having cos in it, then the polar axis, the vertical line, right? This one, it'll be symmetrical. If I have, say, a shape like this, then over here it must be the exactly like this. Okay, now there's no graph like this, but I'm just giving you example. Up and down will be same. What is the importance in this? That means I do not need to find the graph, plot the graph for all from 0 to 2 pi. What do I do? From 0 to pi, that's it. That is 0 to 180 degrees enough, because whatever is the shape over here will be the same shape over here. I just don't know why this shape keeps coming, because I'm trying to do some other shape, say like this. Okay, now this and this will be the same. So why do you want to do 0 to 2 pi? Just do 0 to pi, that is 0 to 180 degree, and then just freehand the other side, or exactly the same points on the other side. So this will save you a lot of time. Now coming to the sine graph, sine function, it is symmetrical with respect to theta equals pi by 2. That means it's the vertical line. If you have, say, a shape like this, then left side will be the same thing. Okay, this is not equal, but in reality it'll be symmetrical. Okay, I hope you understand the concept. Now we will see some problems. Over here they have written, see, r equals 3 plus sine theta is symmetrical with respect to the line pi by 2. So whatever is over here will be over here. Now let's see some problems. We have over here, use symmetry to graph r equals 1 minus 2 cos theta. Cos is symmetrical to the polar axis. So make table of values, but the given equation is symmetrical to the polar axis. So just use from 0 to pi. Okay, make a table of value from 0 to pi, 0, 30, 60, or however you can take the interval, and put the theta value over here. You can take in degrees. Just now we have solved the same type. We are doing again the problems, and now it's 1 minus 2 cos theta. Apply these over here instead of theta, these values, and you'll get these answers. Now sketch the values over here. Let us start sketching 0. Now where is 0 angle? Over here. What is the value of r? Minus 1. So when it's 0, don't go to the right side one, it's minus 1. So this is the first point. Next, pi by 6. Pi by 6 is over here. Now it's minus 0.7. Instead of this, you go to the opposite direction, minus 0.7. Same way, pi by 4 over here, it's in the middle. Over here, go to the opposite direction, minus 4. Now pi by 3 is over here, but it's at 0. Then you have pi by 2 as 1, and you can plot the remaining points. You get like this. You will plot so much. So when you draw, see, look, you'll get like this line. Okay. Then the symmetrical line would be opposite. Now looking at this, you know the shape is Lamasan. Okay. Now over here, looking at the standard form, if you remember the classical curves, you can tell this is Lamasan. Okay, so that is one way you can easily tell it. Or looking at the shape of the graph also you can denote it. So this is how we can graph. I hope it's clear. Very simple table of values and graph it up. These are the classical curves. Now over here we have a real world problem which says during a concert a directional microphone was placed facing the audience from the center of stage to capture the crowd noise for a live recording. The area of the sound the microphone captures can be represented by R equals 3.5 plus 3.5. I'm sorry, this is 0.5 sine theta. Suppose the front of the stage faces due north, Graph the polar pattern of the microphone and describe what polar pattern tells you about the microphone. Now, what it says is we need to graph this equation basically. Now, there is a concert going on and a microphone is placed somewhere over here. Now, the capacity of the microphone that can record the sound, if you keep a microphone over here, not all sound will be recorded. It has a certain capacity. Now, say this is its capacity. So, all the sound over here will be recorded by it, not something so far away. Okay. So now, when we graph this equation, we will come to know the capacity of the microphone. Let's do it. So same like the previous problem, make the table of values, but remember it is sine, so it is symmetrical with respect to the line pi by 2. That means just see it's pi by 2, right? So all that is over here will be symmetrical to the left side. So just mark, plot from this negative pi by 2 to pi by 2. Now, why we take negative pi by 2, or you can take it as 3 pi by 2 as well. It's 270 degree, or from here it is minus 90 degrees, right? To positive 90 degrees. So just plot points from there. The table of values, you're taking values from minus 90 degree to positive 90 degree. Take some interval, put these values over here. You can take it in degrees, put over here, solve, you'll get these answers, and then sketch the graph. When you graph, look over here, this is the shape. Now you do not need to do the entire till 2 pi, just minus pi by 2 to pi by 2, and you got the shape like this. Now then you can extend, the shape will be symmetrical in the other side. That is how we get it. Now looking at the shape, you can tell it's a cardioid. Or looking at the equation, look over here, A and B values are same, isn't it? 3.5, 3.5. That means it's a cardioid. Now, what does it say? Like, look, we have to solve the second problem, right? Part B, information about the microphone. What does it say? The polar pattern indicates, look at this figure. This is a cardioid, okay? Which means if this is see, over here is the microphone. This is the microphone. Up until 7 units directly in front, vertical distance, until 7 units, it can record the sound. But at the right and the left side, it's only 3.5, 3.5. See, it's only 3.5 over here and 3.5. Whereas in the vertical, it is up to 7. That is what it says. So 7 units directly up front, it can record, and it can also record 3.5 units to the left side or to the right side. That is the capacity of this microphone. That is what it tells us about the microphone. Similarly, there's a check problem. I would kindly request you to pause the video, read the problem, and graph the equation by yourselves. I hope you paused it and try it by, when you try and solve problems by yourself, you get confidence to solve more problems. And during the exams, you will never be scared of any problem. You'll be more confident to solve. That's why try solving by yourselves, okay? Now let us see this how to solve it. Here the equation is given. Looking at the equation, I can say it's a cardioid, isn't it? A and B value are same. Now let us make a table of values. Over here also we have sine, so that means it is symmetrical to the line pi by 2. Make values from negative 90 degree to positive 90 degree. Find the value, put these in the in the theta and solve R values, and then you can just easily graph. This is it. Now graph one side and the other side is symmetrical. Again, we got a cardioid. That's it. This is the answer. So it is very straightforward. It's a real world problem, but mainly they have just asked you to graph over here. That's it. Okay, of the two lights. So this is the answer. It is very, very simple. Just remember, when it is sine, it is always symmetrical to the pi by 2. So the interval is from minus 90 to positive 90 degrees. Whereas when it is cos, it is from 0 to pi, the interval, because it's symmetrical to the polar axis.